Hello everyone, welcome back to AGC Maths World. We are in exercise 1.4 real numbers. So now see, prove that following are irrational numbers. So first one is 1 by root 2. So now on the contrary, in the sense actually here 1 by root 2 is irrational number, we know that. But in the opposite we are taking that on the contrary, suppose that 1 by root 2 is a rational number. Let us assume that 1 by root 2 is a rational number. So then 1 by root 2 is a rational number, then it must be in the p by q form, right? So then it is in the form of p by q, where p and q are integers. Now therefore 1 by root 2 is equals to p by q, where p comma q are not equals to 0. That is a condition of rational numbers, right? Now root 2 equals to q by p, again it is in the form of a by b form. So therefore root 2 is a rational number, and it is a contradiction. This contradiction arises. Why this contradiction arises? Due to our assumption. What we assumed that? We assumed that 1 by root 2 is a rational number, right? So that is a wrong assumption. So due to our wrong assumption, so 1 by root 2 is a rational number. So hence 1 by root 2 is irrational number. So that's all about the first question. Now see the second question, that root 3 plus root 5. So now we need to prove that root 3 plus root 5 is a irrational number. Okay, on the contrary, in the opposition, on the contrary, let us consider that. So let us consider that root 3 plus root 5 is an rational number. Okay, Rn in the sense rational number. Okay, then let root 3 plus root 5 is equals to p by q. If it is a rational number, means it must be in the form of p by q form or a by b form, right? So you can take anything, p by q or a by b, no issue. So then p by q form, where q is not equal to 0. Now squaring on both sides to remove the square. So to remove the square root, so root 3 plus root 5 whole square is equal to p by q whole square. Then it is in the form of a plus b whole square formula. So a plus b whole square formula, expand it. Okay, so then a square, that is nothing but root 3. So root 3 square is equals to 3. Why? Because here square, here root gonna cancel, so it becomes 3. Okay, now a square plus b square plus 2ab, 2 root 3 into root 5. So we know that root a into root b equals to under root ab is a formula, right? So here root 3 into root 5, that is root 15. Okay, that is 2 root 15 I written here. So p square by q square. Now 8 plus, so 3 plus 5 is 8. 8 plus 2 root 15 equals to p square by q square. Then send this 8 that side, it becomes minus 8, negative 8, right? 2 root 15 is equals to p square by q square minus 8. Then send this to that side, it becomes the denominator. So here p square minus 8 q square by q square, root 15 is equals to p square minus 8 q square by 2q square. So here it is in the form of p by q, yes or no? Then where p and q are integers, p and q belongs to integers. Okay, so p and q belongs to integers, right? So p and q being p and q being integers, then p square minus 8q square by 2q square is a rational number. Yes, why? Because it is in the form of a by b form. So this leads to root 15 is a rational number. Then it is a rational number or not? Yes, root 15 is a rational number. But is it true? No. Because of our wrong assumption, it got as a true. Our assumption is what? So root 3 plus root 5 is a rational number. So that's the reason we got the wrong assumption. So this leads to root 15 is a rational number. This contradiction arises due to our wrong assumption. So root 3 plus root 5 is an irrational number. Hence it is root 3 plus root 5 is an irrational number. This is all about your second question. Now see the third question. What is third question? 6 plus root 2. So we know that 6 plus root 2 is an irrational number, but on the contrary, on the opposition we will take, assume that root 6 plus 2 as a rational number. So if the 6 plus root 2 is a rational number, then 6 plus root 2 is in the form of p by q, where q is not equal to 0. That is a rational number condition. So here same I written. So root 2 equals to p by q minus 6. Send this 6 that side, it becomes minus 6. So now cross multiply it, then p minus 6q by q. So now root 2 is in the form of what? It is in the form of a by b form, right? So it is in the form of rational form. So root 2 is a rational number. But is it true? No. This is a contradiction. Yes, it is a contradiction. This contradiction arises due to our wrong assumption. What we assumed that? We assumed that 6 plus root 2 is a rational number. But it is not a rational number, right? So hence 6 plus root 2 is a irrational number. Now see the fourth question. This is a different scenario. So root 5 is a rational number. We have to prove. We have to prove as root 5 as irrational number. See the fourth question. Root 5. We need to prove that root 5 as irrational number. So see root 2 in the example problem, root 2 is given as it is same, but the number change, it is root 5. That's it here. So let us assume, on the contrary, assume that, let us consider root 5 as a rational number. Then if root 5 is a rational number, then it is in the form of p by q form. So root 5 equals to p by q form. So if pq have the common factor, on cancelling the common factor, let it be reduced to the a by b. First, suppose if p comma q have any common factors, okay, so then by cancelling, then we will get the a by b form. So a by b form, there is no chance to cancel anything here. So a by b are co-prime numbers. HCF must be the 1. Okay, right, see here. So if p comma q have common factors, on cancelling the common factors, let it be reduced to the a by b form, where a b are co-prime numbers. So for the co-prime numbers, HCF is 1. Okay, right. So now root 5 is equals to a by b, reduced form. Okay, a by b form. Now squaring on both sides, then square and root going to cancel. Then 5 equals to a square by b square. So then move here. So cross multiply here. So then 5b square is equals to a square. What is meant by 5b square is equals to a square? So here 5b square is equal to a square is nothing but, so 5 is going to divide the a square. 5 is going to divide the a square. B square is equals to a square by 5. So what is it saying? That statement is saying that 5 is going to divide the a square. 5 divides the a square. If 5 divide the a square, then 5 also divide the a. So a also divided by the 5. So then 5 divides the a. Okay. Then now take a equals to 5c. Now a considered as a 5c, where c is any integer. Okay. Any integer. C is any integer. Then a equals to 5c. Then substitute this is in the equation 1. For suppose consider this as equation 1. So here I am writing equation 1. Okay. 5b square is equals to a square value how much? 5c. So a square value, a value is what? 5c. A square value is 5c whole square. So that is nothing but 5 square is 25 and 5 1 is 5. 5 1 is 5. 5 5 is 25. So then finally we will get, simplifying after, we will get b square equals to 5c square. What is meant by b square is equals to 5c square? So it is nothing but, here 5 is going to divide the b. 5 is going to divide the b square. Then if the 5 is going to divide the b square, then that at the same time it will going to divide the b also. 5 divides the b square and then 5 divides the b also. Then 5 divides the both a and b. See here, in the first scenario it is dividing the a, in the second scenario it is dividing the b. So what we assumed first initially, a, b are co-prime numbers except 1, there is no factor for the a, b. But here a, b are dividing by the 5. So that's the reason 5 divides both a and b. This contradicts that a, b are co-primes. It is a contradiction of the co-primes, right? Actually co-prime numbers have the only HCF is 1. But here coming 5 also dividing the both a and b. So this is a contradiction, right? This contradiction arises due to our wrong assumption. Yes or no? What we assumed that? We assumed that root 5 is a rational number. But it is not a rational number, right? So that's the reason, hence our assumption is wrong. So we proved that root 5 is a irrational number. Now see the fifth question. What is the fifth question here? 3 plus 2 root 5. So on the contrary, let us assume that 3 plus 2 root 5 is the rational number. Okay, so 3 plus 2 root 5 is a rational number. Then if it is a rational number, it is in the form of p by q form. Okay, so I written here p by q form where q is not equal to 0. So then send this 3 from LHS side to RHS side, it becomes minus 3, and 2 root 5 equals to p minus 3q by q, and send this to that side, it becomes denominator root 5 equals to p minus 3q by 2q. So here p, q are being integers, so it is in the form of rational number. Yes or no? Yes. So now root 5 in the form of rational number. Is it root 5 is a rational number? No. Root 5 is not at all a rational number. So this is a contradiction arisen for us. Why? Because this contradicts the fact that root 5 is an irrational number. So it is saying that root 5 is an irrational number. It is not a rational number. So this is due to our wrong assumption. What we assumed that? We assumed that 3 plus root 5 is a rational number. But that is our wrong assumption. So because of our wrong assumption, we got that 3 plus root 2 5 is a rational number. But it is not a rational number. Hence 3 plus root 2 5 is a irrational number. Okay. This is a proof for the 3 plus 2 root 5 is a irrational number. So that's all about the first bit.